I welcome you to this online tutorial. We are going to continue from where we stopped. This is Mwalimu Arnold Sekago. So we are still on Formulae, Stoichiometry and Mole concept. And today we are going to continue with our items. We're going to continue with our items. I still remind you that if at all you have any queries, any questions, feel free to reach out to me on those respective contacts which you all have. Now, escape. We had covered item 1, item 2, and item 3. All those items 1, 2, and 3, they were on determining percentage composition of different elements within given compounds. So today we are going to see items that involve stoichiometry and the different concepts. We can have stoichiometry and mass, stoichiometry and volume. So stoichiometry here, basically we are going to relate, what are we going to do? We are going to relate what is given to what is wanted, what is given to what is not known, or to what is wanted. So in this item, what do we have? The item, an investor intends to establish a company specializing in production of substances specializing in production of substances based on the melting points of elements used. He needs to first understand the specific melting point trend observed across the given elements, which would enable him to produce different chemicals. For preliminary small-scale experiment, he wants to produce 300 grams of aluminium oxide to be used in ceramics to enhance luster and provide glassy appearance. Production is done by passing steam over strongly heated element as shown in this equation. So this is the equation where aluminium is passed over steam to form aluminium oxide and hydrogen. So the task here, I remind you that this is not how these items look like. No. For me, I am just interested in Formulae, stoichiometry and mole concept. So if I'm interested in the mole concept, then I'll cut out the rest. Otherwise, they always tell you to first categorize, give properties, explain trends, give dangers, but I'm not interested in all those things as of now. So I'm only interested in the calculation, in the part that has mole concept from here stoichiometry. So here we are tasked to calculate the mass of elements needed to react with the steam. So the mass of elements, the element which is being talked of here is aluminium. So we want to determine mass of aluminium. However, we relate with what is given. This item is providing us with, he wants to produce 300 grams of aluminium oxide. So the item is providing us with the mass of aluminium oxide. Then we are tasked to find, we are given mass of aluminium oxide, we are tasked to find mass of aluminium. Hope you've seen what we are given. We are given mass of aluminium oxide. So this is the response. We are given mass of aluminium oxide. So we are going to relate mass of aluminium oxide to mass of element aluminium, which is required. So what you have to do is to summarize the pathway. To relate, you have to relate what is given, what you have. So that's why I'm starting with mass of aluminium oxide, simply because it is what I have. So I am going to relate it to what I want to determine. So from mass of aluminium oxide, I'll find moles of aluminium oxide. Because mass can be converted to moles, but if I convert it directly, if I convert that mass to moles, then the moles will be those of aluminium oxide. Then I can use the given equation. Recall that in stoichiometry, you relate amounts of reactants and products. You relate amounts of reactants and the products. So since I'll be having moles of aluminium oxide, I can relate moles of aluminium oxide to moles of aluminium. Therefore, that will enable me find moles of aluminium. Then I'll convert moles of aluminium to mass of aluminium. So this is the summary of my pathway, implying that this is how I'm going to move. I'm going to convert mass of aluminium oxide to moles of aluminium oxide. How do we convert mass to moles? So if you are watching this video for the first time, we saw this concept of converting from mass to moles. I'll refer you to the previous videos where we've done these calculations of converting from mass to moles. These things have been covered already from the previous videos. So number of moles, we saw that number of moles is equal to mass of aluminium oxide. Since in this case I have aluminium oxide over RFM of aluminium oxide. Mass of aluminium oxide from the item was given as 300 grams. And for RFM we use relative atomic masses of these elements to obtain RFM. We use relative atomic masses of the elements, and those relative atomic masses, they are always given. Like here, you are seeing L equals 27, O equals 16. That is the information which we use to find RFM. So in this case, what shall we have? A number of moles are now equal to the mass is 300 over RFM. AL from the information in the bracket, AL is 27, but there are 2 of them, so 27 times 2. Then plus O is 16 from the information in the brackets, but there are 3 of them, so plus 16 times 3. So therefore, computing this gives us 2.9412, and these are moles of aluminium oxide. Now I have moles of aluminium oxide. I relate these moles to moles of aluminium. So what do we do here? So we have the equation. So we use the concept of mole ratio. What are we comparing? We are comparing what we have. What do we have? We have aluminium oxide. So you start with what you have. What I have is aluminium oxide, yes. So mole ratio of aluminium oxide to, you start with what you have. In simple terms, what you want to find must always be on your right. Comparing this, so the ratio of aluminium oxide to that of aluminium. Then we feed in these ratios. From the given equation, maybe I take you back to the equation. From the given equation, what do we have? From the given equation, aluminium oxide, we only have one aluminium oxide. It is one thing. Therefore, we call that 1 mole of aluminium oxide. This is 1. However, for aluminium, there are 2. Are you seeing the 2 which is before aluminium in this equation? The 2 before. So we have 1 aluminium oxide and 2 aluminiums. We compare balancing coefficients. We compare digits that come before. Here, I do not have anything. In simple terms, there is a silent 1. Yes, there is a silent 1. So implying that this is 1 and these are 2 of them. Therefore, what shall we do? We shall come and say that mole ratio, aluminium oxide, that is 1 mole. 1 mole of aluminium oxide is produced by 2 moles of aluminium. Therefore, what of the 2.9412, since they are the moles which I have, what of these moles with 2.9412 of aluminium oxide? For this case, we shall have 2 over 1. Yes, 2 over 1 times this. Therefore, this is equivalent to 2 moles over 1. So we divide this over this, then multiply with 2.9412. Therefore, computing this, we obtain 5.8824 moles of aluminium. Then I have moles of aluminium. I convert these moles to mass of aluminium. What do I do? Still, to convert moles to mass, we use number of moles is equal to number of moles is equal to mass of aluminium. In this case, I want to find, in this case, I have moles of aluminium. So the mass is mass of aluminium. Since the moles, I have moles of aluminium over molar mass of aluminium. This molar mass, let it not confuse you. Molar mass is obtained in the same way as RFM. So they are obtained in the same way. So therefore, feeding in the number of moles are now 5.8824 equals mass, which I want to find, over molar mass. It is now 1 atom, Al. It is 1 atom, Al, and from the information in the bracket, Al is 27. Therefore, this implies that if we cross multiply, if I have this, if I have 5.8824 equals mass over 27. So to make mass the subject, we cross multiply. We cross multiply. So this 27 will multiply with 5.8824. Then over, there is a silent one here. So mass will multiply with a 1. Therefore, this implies that mass is equal to 27 times 5.8824. And this gives us 158.8 grams of aluminium. So as a result, this is the required mass of aluminium. So this is approach one. However, there is a technical approach. Method 2. This is method 2. Method 2, this method requires use of the given equation directly. So we are going to use the given equation directly. And it is a technical approach. It requires you to be a bit technical. For you to be a bit technical, you must interpret things carefully and reasonably. Yeah, that's why I call it a technical approach. For the technical approach, we use the equation directly. Starting with what we have. We have aluminium oxide. Don't forget that. We have aluminium oxide. What does the equation say? The equation is here. Here is the equation. The equation says that the technical approach requires you to interpret it carefully and reasonably. What does it say? It says that the equation says that one aluminium oxide is here. 1 mole of aluminium oxide is produced. I am saying it is produced because it is on the right. Things on the right are always produced by things on the left. Therefore, we are going to say that 1 mole of aluminium oxide is produced by 2 moles of aluminium. Now you will ask me, why haven't you talked of hydrogen and steam? No, these are not required because they are not being discussed anywhere in the item. The item has provided me with mass of aluminium oxide. It is now tasking me to find mass of aluminium. So I compare these two which are being discussed. So the equation says that 1 mole of aluminium oxide is produced by 2 moles of aluminium. As a result, we go back. As a result, what shall we say? We shall say that 1 mole of aluminium oxide is produced by 2 moles of aluminium. Then from there, this 1 mole you are seeing, previously we saw earlier on that 1 mole means RFM. So in simple terms, 1 mole of aluminium oxide is the same as RFM of aluminium oxide. Therefore, we substitute RFM of aluminium oxide. And RFM of aluminium oxide is Al from the information in the bracket. Al is 27, capital O is 16. So we shall have 27 times 2 since there are 2 atoms, plus 16 times 3 since there are 3 atoms of oxygen. So that this mass of aluminium oxide these grams of aluminium oxide are produced by, now these are 2 moles of aluminium. 2 aluminiums, that's what it means, 2 aluminiums. And each aluminium is 27. So if there are 2, we shall have 27 times 2. 2 times 27 grams of aluminium. Therefore, computing this is equal to 102 grams of aluminium oxide are produced by 27 times 2, 54 grams of aluminium. Then what of 1 gram? If 102 grams of aluminium oxide are produced by 54 grams of aluminium, what of 1 gram? You have what should I use? You have 300 students. 300 students consume. 300 students consume 600 kilograms of portion. Think about this carefully. 300 students, 300 students consume 600 kilograms of portion. Abayizi bisatu balya kilo 600 ez'akawunga. So on average, one student will consume 600 over 300. Therefore, having that in mind, 1 gram of aluminium oxide is produced by, we shall have 54, we divide this over 100, 2 grams of aluminium. Then what of the mass in question? They were 300 grams. 300 grams of aluminium oxide are produced by, if 1 gram is produced by this, then 300 grams are produced by, we multiply 54 over 100, 2 times 300 grams of aluminium. Then computing this, we shall have a mass of aluminium as 158.8. This approach is technical. It is not detailed, but it requires you to write things carefully, interpret the item reasonably, use the equation very well. As of now, I pause this. I pause this. I pause this.